So let's make Excel go through its paces of doing calculations. So to start that, we put in an equation which begins with an equals. And I'm going to come here to cell B3, put in an equal sign, and I'm going to say my position, or the perp's position in the future, is based on the perp's position in the past, which is the cell above. Click on that, plus the velocity that the perp is traveling, which is the cell immediately to the right. Click on that, times the time interval, and that's going to be times 1. A lot of people go ahead and try to click on the time column or a cell in the time column, but that doesn't work out well. We need the time interval. I'm going to hit return, entering that, and then now what I'll do is, since that's an equation I went elsewhere, I clicked on the cell, went to the bottom right hand corner, and copied that puppy on down. Now I'm going to do similar stuff for the velocity, because the cop's velocity doesn't stay constant since there is ultimately acceleration. I'll go ahead and put in the equation I talked about in the pencast, that my velocity in the future is equal to my velocity in the past, which is the cell immediately above. So I clicked on that, plus the acceleration, which is the cell immediately to the right, times the time interval. Again, it's the time interval, not the time, because that would get all wonky. And since that's an equation I want to see on into the future, I will copy that on down. Similarly with position, the cop's future position is equal to the past position, the cell above, plus the cop's velocity, which is the cell immediately to the right, times the time interval. And I know some of you are thinking, well, why are you multiplying by 1? Because that's just the number. I'm doing that to reinforce that we need to multiply the velocity times the time interval, because later on you're going to have time intervals other than 1. So that's just reinforcing good behavior. I'm going to copy that on down and see what happens to the cop's position. Now, I will tell you that this is an approximation, because since the cop's velocity is changing once she's accelerating, that these positions aren't exact. But for the second project, or the mini project, I will show you how to make it more precise. Now what you do is you go through and you look to see where is it that it appears that the cop and the perp are in the same position. You can see here at the 14th second that the cop's, the perp's at 280 and the cop's only 5 meters behind. But in the next interval, during that interval, the perp is at 300 and the cop is at 330. So we know that it's somewhere in this interval that the cop catches up, which means that the rest of these data are not necessary. So I'm actually going to get rid of them, because I don't need them. And so those are the data that are useful to us. Now, it's something that I'll show you how to do it for one set. So I'm highlighting column A, column B, and then I'm going to do column E. And I'm on a Mac, and I'm using the Apple key to select those so that I'm not selecting the ones in between. I think it's Control on a PC. Then what I'm going to do is I'm going to insert a chart, and you can't see that, it's not on your screen, but I went to the Insert menu and then chose Chart. And then the type of chart, you can see up here, it's XY scatter, so I'm going to select that. And then I like this version of it, so I'm going to choose that. And what I see here is a beautiful chart that shows the cop and the perp. Aren't you amazed? You should do that for time and the 2 velocities, and then time and the 2 accelerations, so you get that kind of practice. So go ahead and set up this spreadsheet. Make the 3 charts, the position, velocity, and acceleration versus time charts. Okay, thanks. Enjoy.